Okay, let's go ahead and graph this one right here. P equals t squared minus 2t plus 4. And so I have that equation here, and I'm going to substitute some values in for t. These may not be the best values to substitute in to graph it. Right off the bat, I know it's going to be a parabola because the t is squared. And also, since the leading coefficient, the number in front of the t squared, is a positive, it's actually a positive 1, I know it's going to be opening up. So let me substitute negative 3 in for t, so that would be negative 3 squared minus 2 times negative 3 plus 4. If I work this out, I get, well, that would be 9. 2 times negative 3 is negative 6, and a negative of that makes plus 6 plus 4. So that would be 10, that would be 19 right there. If I substitute in negative 2 into it, that would be negative 2 squared minus 2 times a negative 2 plus 4. And if I work that out, I'll get, well, this is 4, this is another plus 4, plus another 4 right here at the end, so that would be 12. At negative 1, when I substitute that in, that would be negative 1 squared minus 2 times negative 1 plus 4, which gives me 1 plus 2 plus 4, which is 5. When I substitute 0 in for t, well, that's going to be 0 squared minus 2 times 0 plus 4, which is 4. When I substitute 1 in for t, that would be 1 squared, which is, well, let's do that here. That would be p equals, substituting the 1 in for t, it would be 1 squared, which is 1. 1 times negative 2 is minus 2 plus the 4. And what does that give me? Well, that's 5 minus 2, which is 3. Let's substitute the 2 in. That would be p equals 2 squared minus 2 times 2 plus 4. And if I work that out, I get that's 4 minus 4 plus 4. Well, it's at 4. Now, watch what I get when I plug 3 in. I think I'm going to get 5. Let's see what we get. When we substitute 3 in, we get 3 squared minus 2 times 3 plus 4. I'm just substituting the 3 in for the t. And that would be 9 minus 6 plus 4. Well, this is 9 minus 6 is 3. And 3 plus 4 is actually 7. So let me check this one more time. 3 squared minus 2 times 3 plus the 4. That would be 3 squared is 9. 9 minus 6 is 3. 3 plus 4 is 7. And that doesn't seem right to me. So let me check this negative 1 one out. Here, if we check negative 1 when that was evaluated, that's right here. That's negative 1 squared, which is 1, minus 2 times negative 1, which makes plus 2 plus 1. Well, right here, that's 7. So that point right here at negative 1 should be 7. Now, the reason I knew there was a mistake is because it should be symmetric here. So it went up to 4, so this should go on up to 7. So it's a good way to catch your mistakes here. I got a point at negative 3 and as high as, what, 19. So I'll tell you what, let's go units of 5s here. 5, 10, 15, 20. And so at negative 3, we're at a height of 19. At negative 2, we're at a height of 12. At negative 1, we're at 7. At 0, we're at 4. At 1, we're at a height of 3, though lower than 4. At 2, we're at a height of 4. And at 3, we're at a height of 7, back up here. So what would we get if we substituted 4 in? Well, we don't need to do that because I can see the pattern here. 3, there's a 4 on each side, there's a 7 on each side of that. See, this is the lowest spot on this. This would be called the vertex point. And when I substitute 4 in, I'm going to get the next number up there. I would get 12. So at 4, you're going to get 12. And what does this thing look like? Well, it's a parabola. But instead of the lowest spot being on the y-axis, it's been shifted over. It's not even on the x-axis either. So this graph looks something like that. Here's the minimum point, which is the vertex point on that parabola. So the vertex point is actually at the point 1, 3, that point right there, and it's a parabola that's opening upward. And if you graph the next one on the sheet, you would see that that's a parabola opening downward, this one right here. Okay, so we'll save that one and maybe one more for the next video.